I went down the scrapyard a couple of days ago, took some odds and ends of cable, this and that. Anyway, in amongst the wire was this big roll of very handy cable. And I know what size it is, but a lot of these cables, they used to have the size printed on them, but not anymore. So what I thought I'd do, because a lot of people are not familiar with this sort of thing, we'll go through how to measure this type of cable. So let's zoom in. So the cable size is to do with the solid copper core. So it's the cross-sectional area of the copper. So you can't just measure this, because there are 7 strands there and there's a load of gap between it, so you have to measure each individual strand and then do a bit of arithmetic. So first of all, we'll get a vernier caliper, switch it on, and it's on millimeters. Try and do it so you could see it. Let's just get it square. It's 1.06. Let's try another one. 0.93. 0.94. 0.99. I'm assuming the average is about 1 mil, and there are 7 of them, but we need to work out what the cross-sectional area of that is. So let's just work this out. The diameter is an average of about 1.05 millimeters. Okay, now to get the area of a circle, you need to use a formula which is pi, and don't worry about that, that's just a constant, multiplied by the radius, multiplied by itself, and we write that as squared. So pi is 3.142, and if the radius, if the diameter is 1.05, then the radius will be 0.5, and that's probably, let's round it down to 2. Okay, we want 3.142 multiplied by that again. Okay, so we'll just get the calculator out. Hopefully you can see that. 3.142 multiplied by 0.52 multiplied by 0.52 equals 0.849. So let's call that 0.85 equals 0.85 millimeters square per strand. Then we need to multiply that by 7. We'll multiply by 7 equals 5.95 millimeters squared. Okay, so it's 6 mil cable. Just to take this a bit further, because it's an ever expanding subject, the fatter the wire, the more current go through it, and the lower the voltage, the more current's required for the given amount of wattage. So let's say a kilowatt at 50 volts is nominally 20 amps, but a kilowatt at 12 volts is nominally 80 amps. So the lower the voltage, the fatter the cable needs to be. Now I've just got another example. This cable here, it's somewhat fatter. So you need to be square on to this stuff, because if you're at an angle it will give you a seriously inaccurate reading. So what's that? 2.07. Let's try another one. 2.12. Let's say an average is 2.1. So if you use a cable that's too small for the given current, you'll get what's called volt drop, where say you send 10 amps in one end, you'll get 10 amps the other end, but it might be 50 volts and you might only get 45 volts the other side, the other end of the cable. And of course, with Ohm's law, if you reduce the volts, then you reduce the wattage. You'll have to look at the video about that. I'll put a link, if I remember, in the description. Anyway, we've got a diameter of 2.1 millimeters. So pi r squared 3.142 multiplied by half of that, 1.05, multiply 1.05. Okay, so let's get the calculator out. 3.142 multiplied by 1.05 multiplied by 1.05 equals 346 equals 3.46 millimeters squared. Okay, and so we need to multiply that by 7 equals, multiplied by 7 equals 24.2 millimeters squared. So obviously you can put more current through that cable than the other one.